Hey everyone, my name is Tim Bryan. I like to make sports analytics videos. Today we're going to be looking at this natural language processing library from Hugging Face. So Hugging Face, if you don't know, I found out about it recently. It's like the cutting edge of natural language processing, machine learning. So they actually have like these models you can download to your machine or GPU in the cloud or something. They're pretty large models. You don't have to train them yourself, so it's kind of convenient and they're open source. But essentially, they're very strong natural language processing models. So this one we're going to be looking at today is called RoBERTa Large MNLI. When you download it, it's about 2 GB, and it's trained on Wikipedia data, book data from library data set, and then this other natural language processing data set. So what we're going to be using for is something called zero-shot classification. So if you know what machine learning, what regular classification is, essentially you have this training data that you're going to train your machine learning model on. You have all these features like data points, and then based on those data points, there's a label of whether something's a 0 or a 1. So for example, if you're like looking at stock data, you would have maybe the industry, all these different categories or data points on this stock, and then the label would be, is the stock going to go up or down? So you would train it based on that. What zero shot classification is you have a sentence, say like what we're going to be doing today is NFL play-by-play data description. So like Kirk Cousins passed 10 yards to someone, and the labels we're going to be giving the model are, does this play benefit the offense, benefit the defense, or is it neutral? And so we're not training the model, we're just using this existing model and telling it to classify based on the sentence, the words in the sentence, and giving it those labels. Um, if you want to read more about this, I think this model is from a group at Facebook and this school. It's pretty interesting stuff. It's pretty amazing that they give away these models for anyone to use. So let's give it a shot. Something to note here, and I would suggest everybody does this, is I'm using paper-space gradients. It's free. There's a free tier for it, but basically I'm running everything on this GPU in the cloud. Uh, this model is massive, and it's like a couple gigabytes. And I wouldn't recommend you download it on your computer unless you've got the space to spare. But this paper space gradient actually has optimized models, or not models, like GPU. You can optimize it for Hugging Face specifically. So it downloads all these things. It should run faster, and everything's kind of downloaded Hugging Face related. So we're just going to install, to get the play-by-play data, we're going to install this NFL Data Pi package on the machine. We're going to import the library's transformers, and it's a pipeline. So we're piping in this model that I mentioned a second ago, rather than training it from scratch ourselves. We're going to be using pandas for obvious reasons, and then we'll plot our results in matplotlib. So here we're going to define our classifier as the zero-shot classification, and this is the model we're using. So there you go. As you can see here, it's like 1.3 gigabytes. It's pretty big. I'm sure there's bigger models, but anyway. We're going to use 2022 data. I'm just filtering it down to this one game, which is Week 4, Minnesota, New Orleans. And the reason I'm doing that is because it takes quite a while to train. It takes about 10 minutes for it to classify each play in a single game. So if you did a whole season, it may take a couple hours. Who knows? So the only columns we need are this game ID, so we can filter down to it, the description of the play, and then the expected points added of that play. So for anyone that doesn't know expected points added, at any given point, the offense has the ball on the field. They're expected to score a certain number of points based on statistics. And let's say they throw the ball 20 yards down the field, they get closer to the end zone, their expected points go up. So the difference between those states and time is the expected points added for that given play. And it could also be negative if the defense gets a sack, which would mean the defense is benefiting. So based on this EPA, expected points added, we're going to add a new column that tells us if the offense benefits, the defense benefits, or if it's a neutral play. So here's our data set. As you can see, an incomplete pass here was a negative EPA. It means the defense benefits. Now we're going to run through the play description through our model. So this is the sequence we want to classify, and here's the different labels. And it's crazy, that you can do this. Normally machine learning, you have to train the model on um, training data where each row is labeled as such. But here, just based on the language alone, we can classify the play as either the offense benefiting, the defense benefiting, or a neutral play. And we're going to put the output in an empty list here. So it's pretty crazy how simple this is. We're just going to create a for loop through the index for each row in the index. We're going to append. We're going to classify the description of the play, and we're going to use the candidate labels as we defined up here. So we're going to ask the model, do you think based on the description of this play, the offense is benefiting, the defense is benefiting, or is it neutral? So here, I've already run it. It takes about 10 minutes, like I said. And again, I would suggest you run it on something in the cloud because you can see here, when I was running this, the CPU usage got up, over 500% usage. I'm not so experienced with using GPUs, so I'm sure there was a way to have this run on the GPU, and it probably would have been faster and more efficient. But I don't know how to do that. So if anybody has any ideas, that would be helpful. But here's some example outputs. So let's see. The description of this play: Andy Dalton pass incomplete short to Callaway. You can see the model is actually wrong here. This is probably a benefit to the defense since it's an incomplete pass. But the model is 43% sure that the offense benefits. So let's look at a couple more examples. Alexander Madison ran for 2 yards. It actually is wrong here too. I picked a couple of bad ones, but it's not as inaccurate as it may seem. So let's see if we can find one that's actually correct. Come on. Okay, here we go. Yeah, Taysom Hill, left guard, ran for 4 yards. Yeah, so the offense obviously benefits here. They got a positive play, so the offense, the model is 48% sure that the offense benefits in this case. And again, we haven't trained this model on any NFL play-by-play data. Like, this is purely just based on the language. It's knowing that, or it thinks that the offense would benefit. So Kirk Cousins sacked for -7 yards. Yeah, it's pretty sure that the defense would benefit here. Let's do one more. Dalvin Cook, right guard, for 1 yard. Again, it's wrong here. I think the defense benefits, but yeah, we're gonna put this as a row or a column in the data frame, the model decision on what it thinks, and then we're just gonna plot the data. So here's our final results. The blue bar is the actual, whether the offense or defense or neutral, what the actual result of the play is. And then the orange is what the model thinks. So this is just for one game and one year. So, it may be better or worse, more accurate or less accurate, but I don't think this is too bad. It's clearly offensively biased. As you saw, there was a couple points where it was wrong. Based on, it tends to think even if it's like an incomplete pass, if the offense is doing something that's not inherently bad, like a sack or something, it kind of thinks that the offense is benefiting. So it's offensively biased, at least for this game, but pretty close. Just based on the play description, this model was able to classify pretty closely whether the offense, defense, or neutral was the result of the play. So kind of interesting. You may be asking yourself, what's the point of this? And I don't really have a good answer for that. I just think it's kind of cool to try out these natural language processing models. So let me know what you think of the video, and thanks for watching.